All of this down here talks about pretty much what we've already discussed. Left, right, up, down, vertical stretch, and vertical compress. In the next section of the notes, we're going to talk about this thing called, and you haven't learned about logarithms yet or anything, but this will make more sense in a little bit. We're going to talk about this thing called the natural base. Now try to understand what I'm going to say. The natural base has a base of e. Now what do I mean? Maybe we should write this down. We live in a base 10. We're used to everything. After you get to a 10 of something, it increases. Like once you get to 10 tens, it goes to 100. Once you get to 10 100s, you go to 1,000. Once you get 10 1,000s, you go to 10,000s. Okay? So what is E? E is the number formed by approaching infinity. And what that means is by plugging in really, really, really big problems into 1 plus 1 over x to the x power. Do you need to know this? This is not a need to know. Okay? It's just, this is not something you absolutely need to know. It's just something that, it's nice to know where these random numbers that I give you come from. Okay? This will have a new type of asymptote. Now the natural base exponential functions come from this equation I told you. These are useful for describing things that continuously grow or decay. Alright? So when do we use this? We use this if we have continual growth or continual decay. Okay, it's not just like every little bit of a time it grows or something. It's always shrinking, it's always growing. That's when you use E. Now, I said let's find E together. Long story short, there is an E button on your calculator. And this gives you the value of E to the first power. Let me go grab a calculator. Okay, the E button is if you hit second ln. By the way, ln stands for natural log, and this is the natural base. See if I hit second ln and I hit enter. Oh, good, I get a problem. If I hit second ln, I gotta type in a 1 here for the exponent. That is the value of E, 2.7182, and it goes on, just like pi goes on forever, E goes on forever. Okay, but how could that be found if you didn't have a calculator? You take this parenthesis and you plug in a really, 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 really big number for x. How many zeros did I use? 1, 2, 3, 4, 5, 6, 7, 8 zeros. I gotta do that up here. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay? If you plug in really, really, really big numbers for x, watch how you get almost what your calculator tells you. You ready? So if you do 1 plus 1 over to the, notice how close that number is. Alright, and the larger the number you get, the more accurate you're going to be. Okay, so if you never had that E button, you could just plug in a super, super big number into this little equation and get E out. Okay. Now, when would you use E? Why was this even invented? This was invented for problems that are compounded continuously. So instead of month by month, or instead of week by week, or year by year, this would be something would be giving interest or giving something to you every single moment of every single day. In 7.1, we learned about things that were compounded annually, which means yearly. Okay, so it was like at the end of the year, boom, it was compounded. At the end of the next year, boom, it was compounded. Now it's compounded every second of every day. This is your formula. My old teacher called it PERT, you know, like the shampoo. She called it the PERT formula. The reason she did that is because it's your principal, P, times your natural base, E, to the rate, T, or rate times time. RT. So she called it the PERT formula. That helped me remember it. So let's go to a bank on problem 5, and it's about a scholarship. Suppose you won a contest in 5th grade, and in 5th grade you got $3,000 bucks. We should probably, by the way, label that as P. You put in an account, and the account pays 5%. That's your rate. Make it a decimal, 0.05. And it's compounded continuously. Anytime, here you go, you ready for a silly little rhyme? Continuously use E. I'll say it again. Continuously use E. That tells you that you're going to use E. How much will you have after 4 years? So we're going to put time as 4. This one's going to be measured in years. So we're going to say, what is the amount in 4 years? Look, guys, this is just a function notation. As far as I'm concerned, you can write y equals. I'm just writing it in function notation because you need to be able to understand that really I'm just saying y equals. So I'll do 3,000 bucks times e to the 0.05 times 4. Ready? This is going to be a calculator problem. By the way, I do believe that like basic calculators have e, so don't give me an excuse. You can just go online and search for one. Okay, so you do 3,000 e 0.05 times 4. Look how much money you'll have after 4 years. Not too bad of a problem. Pretty simple as long as you know how to use your calculator. So it's $3,664.20. Please make that 21 cents. Okay, so we'll say equals $3,664.21. Pretty nice problem. Alright, and guys, that's really as hard as this gets. Now you might say, Mrs. L, how the heck is this even in this section? Okay, why would this even be in this section? Come here, let me show you guys the graph of E. I'm just gonna do e to the x power so you can see. Take a look at it. Do you guys see it? It looks just like an exponential graph. That's because E is an exponential graph. Okay, we're talking about all about exponents in this chapter. Alright, we only have one more problem. This one went kind of fast, except for that word problem. It's not too bad, is it? How much will be in the account after 4 years of high school? Alright, well, guys, let's just think this through, okay? You have $3,000, right? Since it's continuously being compounded, because you're leaving it in the bank, you use the letter E. And it's to the 0.05 power times, okay, well, when did you deposit this? It was in 5th grade, right? So after 4 years of high school. So ready? 5th grade, 6th grade, 7th grade, 8th grade, 9th grade, 10th grade, 11th grade, 12th grade. 8 years. You started in 5th. 12th grade then, everybody, would be 8 years later. Okay, you start in 5th grade, therefore the end of high school is 8 years later. So times 8. Well, let's get our calculator and figure it out. Yes, every regular calculator can do this. I think even the basic ones on your computer at home. 3,000 E 0.05 times 8. I gotta close my parentheses. Your fancy calculators at school, you might not even need parentheses. So $4,475.47. $4,475.47. Now, what would be the benefit if a bank continuously compounded? Since we have just a little bit of time, I want to talk about that. What is the benefit of continuous compounding? Okay, like for example, some banks, like I know my bank, I only get my compounding. I only get that every month. Okay, whenever you get something that continuously compounds, here's what you get. You get more money more often. And maybe not more money. Let's just say you get money more often. Let's say you get money more often, and it therefore has more to grow on. So if you put money in, you get interest. And then you get that new balance and you get interest on that. Then you get that new balance and you get interest on that. If that's happening continuously, you're going to get more money in the long run.